Here's an interesting challenge. Let's try to solve an equation with a few operations in it today. Once you get this down, you're going to be able to solve any size equation. So we've got lots of things going on in this equation. Look at that. We've got 2x plus 3 minus 11 equals 14. So here's a new rule. Anytime you see something that you could simplify easily before you start doing opposites, you want to do that first. And that's what we've got in this equation. That 3 minus 11, you know what to do with that. That's just regular old arithmetic. So just go ahead and change that to subtract 8 equals 14. And now it looks like an equation with two operations going on. So here's my next rule. The first thing you want to do is get rid of any addition or subtraction that you can get rid of. So we're going to take care of that subtract 8. We're going to get rid of that first, do it to both sides, of course. And what is left? We've got a 2x on that side, we've got 22 over here. Now we're down to some multiplication. It could be division in another example. Those are the last steps you want to take care of in any equation. So let's go ahead and do that. We're going to divide by 2 on both sides. That leaves us with x equals 11. Don't forget, you should always plug that back in and see if it's the right answer. So think of it as 2 times whatever solution you get plus 3 minus 11 is supposed to be equal to 14. Well, let's see if it is. We got 11. That would be 22 plus 3 minus 11. That is 25 minus 11, which is 14. So we did that one correctly. Let's look at another example. How about 5x plus 7 equals 18? Now, there isn't any math just waiting to be simplified, so we can skip that step. We do have some addition. Let's undo add 7 by subtracting 7. So I've got a 5x left over here, and now I just have 11. The last step is to divide everything by 5. These reduce, and I've got x equals 11/5. Plugging that in is a snap. There's my solution. Now, is that really equal to 18? Well, that reduces. 1 times 11 is just 11 plus 7, and that is definitely 18, so we did that correctly. How about negative 3x plus 14, and that's equal to 7 plus 8x on the other side. So here we have something new again. I'm going to add another step to put at the top of your list. If you see variables on both sides of your equation, I want you to eliminate one of them. Okay, we're going to eliminate a variable. In this case, I think I'll get rid of 8x. You could do either one, but I like to have the x's end up on the left side of the equation so that it reads as a solution from left to right. So I'm going to undo add 8x by subtracting 8x. And I'm going to do that on the other side. I have two terms over here. Let's line it up with the one that it matches. These are like terms, so I'll be able to combine them. Okay, negative 3x, take away 8x more. That's negative 11x plus the 14 that's already there. On this side, all I have left is 7. So now I proceed with my other rules. There's no simplifying, so we're going to go on to either add or subtract to get rid of something. We're going to subtract 14 from both sides. I've still got negative 11x on this side, and now I just have negative 7 on that side. We need to do our last step, which is get rid of any multiplication or division. Remember to divide by exactly the same sign as that number in the numerator, so that when they reduce to positive 1. You've got x equals, don't forget, both sides, positive 7/11 is the answer. When you plug that back in, it looks a little messy. I'm going to start over here. But really, if you just take it step by step, this isn't going to be any big deal. It's all math you know how to do. There's just a lot of steps. So over here, if I go ahead and multiply, I've got negative 21/11 plus 14 equals 7 plus 56/11. I've got a lot of denominators, luckily they're the same, so let's just change everything to 11ths and clean it up a little bit here. That makes 154/11, 77/11 plus 56/11. So on this side, that's basically 154 minus 21, which is 133/11. And on this side, 77 plus 56 is also 133 11ths, so both sides are equal, and we verified that. There's how to deal with two or more operations that should work on any size equation from now on. So go do some.